Hello, and here we go. We are, where am I here? Hello. Chapter 4, Section 2. All right, we're still working with exponents, and we're going to move on and start talking specifically about integer exponents today. So, here we go. You are going to want a calculator. Go grab one. All right, pause the video if you need to. Okay, here's what I want you to do. Here's a little bonus problem I want you to think about. Okay, I want you to find two different numbers that when you evaluate them this way. So it says find the value or find two different numbers that the values of x to the y power and y to the x power are equal. So here's what I want you to think about. Let's say our numbers are 2 and 5. Okay. And I say 2 to the fifth power and 5 to the second power. What I'm looking for is, can you find numbers where those two are going to be equal to each other? This pair doesn't work. 2 to the fifth power, 2 times 2 times 2 times 2 is 32. 5 to the second power, 5 times 5, 25. Those two are not equal. But I want you to see if you can find a pair where they're different numbers, and when you raise each one to the other power, they're equal to each other. Think about that. At the end of the video today, come and show me what you've got. And if you got it right, I'll give you a bonus point. Don't tell anybody else. Okay. All right, let's move on to today's learning target. Learning target for today. Similar to yesterday, we're going to be evaluating expressions with exponents, but today we're going to have zero exponents and negative exponents. And so your job is going to be to evaluate those and see the pattern and understand how it works, and you'll become such masters you won't even need a calculator anymore. All right, so here we go. I'm going to start with powers of 2 because those are fascinating. 2 to the fifth power, if you look at that, 2 times 2 times 2 times 2 times 2 is 32. Let's look at 2 to the fourth power. That is 16. 2 to the third power is 8. 2 to the second power is 4. 2 to the first power, well, that's just plain old 2. Okay? Now, if I asked you what 2 to the 0 power is, do you have a guess? Your eyeballs want to say it's got to be something with 0. But I want you to look at the pattern here. 32, 16, 8, 4, 2. If I follow this pattern, every single time, I'm dividing by 2. Dividing by 2, dividing by 2. So my pattern tells me 2 to the 0 power should be 1. What? Check on your calculator. Honest to goodness. You don't believe me? Do it yourself. I got my old faithful one right here. 2 to the 0 power right there is actually equal to 1. It sounds crazy, doesn't it? It's true. Let's continue building this pattern. If I said, okay, what if I put a negative exponent there? Your eyeballs are thinking, oh, that must be a negative value. But I'm saying, look at our pattern here. Every single time we went down a power, I went down an exponent, you had to divide by 2, divide by 2, divide by 2. That tells me that this should be 1/2. It really should be. Okay? Now, here's the weird part. The weird part is, if you do it on your calculator, it probably gives you a decimal that looks like this, 0.5. Change that into a fraction. Remember how to do that? On the TI-30 multi-views, you've got that magical toggle button down at the bottom above the enter button, and that turns fractions to decimals back and forth and back and forth. So, it really works. That's 1/2. Go ahead on your calculator and plug in 2 to the negative 2 power. Guess what happens when you see the decimal? You get this. Turn that into a fraction. Ba-boom. How about 2 to the negative 3 power? What happens? I bet you get this as a decimal, but when you turn that into a fraction, you get 1/8. What? What about 2 to the negative 4 power? What happens? Oh, you probably get something like 0.0625 or something like that. That's the same as 1/16. What? 2 to the negative 5th power as a decimal? I bet it's something like 3, 1, 2, 5, something like that. That's the same as 1/32. Okay, now I need you to look at the pattern. Okay, 2, well, let's start here. 2 to the 5th power is 32. 2 to the negative 5 power is 1/32. I could also write that as 1/2 to the positive 5 power. 2 to the 4th power is 16. 2 to the negative 4 power is 1/16, or 1/2 to the 4th. 2 to the 3rd power is 8. 2 to the negative 3 power is 1/8. That's the same as 1/2 to the positive 3. 1/2 to the positive 2. 1/2 to the positive 1 power. Did your brain hurt yet? Okay, let's take a look at a few more. 5 to the 3rd power equals 125. Guess what 5 to the negative 3 power is? Don't believe me? Ooh, check on your calculator. Now, you probably get a decimal initially that looks something like this, 8 thousandths. If you put 8 thousandths in simplest form, that's 1/125. In other words, 5 to the positive 3 power. They're crazy. We did 2 to the 4th already. That's 1/16. 2 to the negative 4. Oh, that's 16. This is 1/16. 3 to the 2nd power is 1/9. Don't even use your calculator right now. You should get 1/9. In other words, 1/3 to the positive 2 power. Are you getting the hang of this? I know it seems crazy. Let's look at the powers of 10 for a second. 10 to the 2nd power is 100. 10 to the 1st power is 10. What's 10 to the 0 power? I know you want to say 0, but don't you dare. 10 to the 0 power is 1. 10 to the negative 1 power, check it on your calculator. You're going to get a fraction 1/10. You might see it on your display as a decimal, 0.1, but that's 1/10. 10 to the negative 2 power probably shows up like this, but that's the same as 1/100. Are you getting the hang of this? So we kind of have some rules, okay? We have some rules. And it's kind of hard to write in words. You know what? Let's take a look at a few more with 0, because I bet that still doesn't make sense. So grab your calculator and put in something like this. 17 to the 0 power. Then I'm going to ask you to say 294 to the 0 power. What is 3 to the 0 power? What is, in parentheses, 4 plus 19 minus 12 to the 0 power? Guess what? 1. 1. 1. This, what's that? 23 minus 12. That's like 11 to the 0 power. 1. Oh my gosh. So now what I want you to do is recognize some patterns for 0 and for negative exponents. So basically, for negative exponents, it looks like this. Any number. So if we have a number like this, x, any x number, whatever it is, x to the negative 5 power is going to be the same as 1/x to the positive 5 power. Okay? It's like you put it in the denominator. Okay? Really what we're doing is we're taking the reciprocal, although we're not going to get into fractions now. So for your purposes, it's going to look like it just simply goes into the denominator. If I said x to the negative 20 power, that's the same as 1/x to the positive 20 power. Okay, so I'm writing the rule this way because I think it's difficult to put into words. Okay, but basically you can simply invert it. In other words, use the reciprocal and use the positive power. Okay, so think these two words, reciprocal and then the positive exponent or the positive power. Okay, now we have to do a little bit of work with 0. Okay, what about a 0 exponent? Okay. In fact, let's investigate a little more. What if you had a fraction like 1/3 and you raised it to the 0 power? Grab your calculator and see what happens there. Okay. So you plug in 1/3. Okay. And then you raise it to the 0 power. And what happens on your calculator? Hot diggity dog, you get 1. Okay. What if I put in a negative number? What if I put in something like -5? Wrap it in parentheses. It's important. Okay. And raise it to the 0 power. And let's see what happens. -5 to the 0 power. Wow. That gives me a +1 as well. That's just bizarre, isn't it? What if you tried doing 0 to the 0 power? What happens on your calculator there? 0 to the 0. Uh-oh. That is a big old error. That's something we call undefined. Okay? So let's see what's happening here. Okie dokie. Don't even grab your calculator now. I just want you to think about these. 4 to the 2nd power, you know, is 16. Okay. 4 to the -2 power should be 1/4 to the +2 power, which means you get 1/16. Cool. Leave it as a fraction. Don't change it to a decimal. What if I had an expression in there? Okay. 7 minus 4. Well, evaluate the expression first because parentheses come before exponents. 3 to the 2nd power. Well, that just gives you 9. This one says 3 to the -2 power. Well, now I know what negative exponents means. It means simply use the reciprocal. Instead of 3, I'm going to use 1/3 squared. Or I can write it this way, 1/3 to the +2 power, 1/9. And what if I evaluate this and I have 3 to the 0 power? That's just going to be 1. Isn't that crazy? Wow. Our goal is to get to evaluate things like this, big strings of expressions, and you have some negative exponents, you have some 0 exponents. Right now, that 5 is going to stay the same. Grouping symbols always come first, so worry about 6 minus 4, which is 2. And this can just stay this way, okay, to the 0 power. And again, be very, very careful as you look at your values in raising things, okay? 2 to the -3 power means 1/2 to the +3 power. Anything raised to the 0 power is 1, okay? So this means I have 5 minus 1/8 and then plus 1, which means, let's see, 5 take away 1/8, that'll give me 4 7/8, and then add one more. So I end up with 5 7/8. There you go. Okay, so don't let these weird things freak you out. Here's 3 plus, do your parentheses first. This means I have 3 to the -2 power. -8 to the 0 power, that's just going to be 1. Worry about this, okay? Focus in on this. This is a fraction because you get 1/3 to the +2 power. Okay, I'm going to come over here now. That means 3 plus 1/9 plus 1. Okay, so this is 3 1/9 plus 1 more, 4 1/9. Done. Fascinating, isn't it? All right, so here's what I want you to do. I really want you to try these without a calculator first to train yourself to understand the negative exponents, okay? And if you want, you can go back and check them, but I need you to leave everything written as a fraction, all right? Good luck, and may the force